This is problem 8-104. In parts A through D below, for each polynomial function f of x, the graph of f of x is shown. Based on this information, state the number of linear and quadratic factors the factored form of its equation should have, and how many real or complex, which also means non-real, solutions f of x equals 0 might have. Assume the polynomial function of the lowest possible degree for each one. And there's an example here. So f of x at the right will have 3 linear factors, therefore 3 real roots and no complex roots. So let's see what that means a little bit more. What things that they want you to figure out is either it's linear or a quadratic factor. So that's one thing we have to identify for each of these problems. And then real and complex solutions, which also means roots or x-intercepts. Okay? So we have 2 things to identify in each problem. So looking at this example, the factors means how many parentheses you have. Okay? And that is related to what the solutions are. So let's just say, for example, a linear factor would be like x minus 5. So that would be a root at 5, which isn't on here. So poor example. So this is the factor. The root would be 5. Okay, and that would be real. So this is a linear factor. This would be a real root. If I have something like x squared plus 4, that is a quadratic factor. And if you set this equal to 0, you are going to get x squared equals negative 4. And if I square root both sides, that's when we get the complex going on. Remember, we have i's and stuff. Okay? So we'd have 2i and then negative 2i. So this is a quadratic factor, and that creates a complex root. So those are the things that we have to talk about here. So in this example, there are 3 places where it crosses through. There would be 3 separate factors, little parentheses here, and that means that they are linear. They would all look like this. And then there are 3 real roots because they're all separate and different roots. They're all different x-intercepts, okay? So let's look at these problems together now, where we're doing each of these things, the factors and the roots, describing the roots. So let's look at A. Let's talk about the factors first, which is how many parentheses you have, basically. So we're going to have 1 here, and this is a double root, okay? But that would mean that looks like it's about at 1, so that would be x minus 1, and we could just write it a second time. So that does not mean it's quadratic because we could have written it as x minus 1 squared. We're talking about if the squared is inside the parentheses. So this is just 1, 2, and then another linear root. So we'd have 3 factors. That's what I meant. 3 linear factors. We'd have 3 of these. We could have combined this to right here, but this is not what we're referring to as quadratic. We want that. If it's quadratic, it would be an x and then a squared inside the parentheses, which is not what this means. Okay? The roots is the actual value of the x-intercepts. How many of those do we have? Well, we have 1 here, and that's a real number, and then we have 1 here. Okay? It's a double root, but it's only 1 value. The number 1 happens. Okay? I'm not going to write 1 and then 1 again. It's just, that's the value. So it would be at about negative 7 and 1. So that means we have 2 real roots. And 1 was a double. This one was a double root right here, but we're only going to write it 1 time because the value 1 it just happens there. I'm not going to write, you wouldn't write the roots are negative 7, 1, and 1. You would just say negative 7, 1, and this is a double. Okay, so hopefully that makes sense. Let's look at B. So talking about the factors, which again is the number of parentheses that we have. Okay, so we'd have 1 here. This is going to be a quadratic root or quadratic factor right here because it becomes a complex root. So we're going to have 1 linear from this, and we're going to have 1 quadratic root. So from my example over here, you saw that 1 quadratic factor made 2 complex roots, right? It's always plus and minus I. They come in a pair. So we have one factor that's quadratic, but the number of roots we have, which is again the value, we have one at like -7, so that's one real. And we'd have one at, you know, plus 2i and one at minus 2i. So really, those are two different numbers. So we're gonna have two complex roots. Okay? This is for this problem right here. Okay, so it's not necessarily the same number of things here, just like this didn't match up. So we have one linear factor. This would be, you know, x squared plus something or whatever, and we'd solve it and get two complex out of that factor. It's a little hard to understand, but I think you'll do okay. So for C, number of factors, which is the number of parentheses that we have, we'd have 1 here, 2, 3, 4. So we have 4. And they all just go straight through, so 4 linear factors. Okay. Then we're going to talk about the roots, so the actual number of the x-intercepts, the value of the x-intercepts. We have 4 separate numbers that they go through. So we're going to have 4, and they were real roots. They cross the x-axis, so they're real, not complex. Okay, so that one should be a little bit more straightforward. And then D, the factors, how many parentheses we have. We're going to have one quadratic factor there and 1, 2 linear here. Okay, and then for the roots, which is again the value, we have 2 separate complex roots here, right? Like plus 2i and minus 2i, for example. Okay, so we're going to have 2 complex right there. And these are 2 different roots, and they're linear. I'm sorry, they're real because we just go through the x-axis. So 2 real. Okay, it's a little bit hard with all the terminology and knowing when to say what. But knowing that, you know, the factors is how many parentheses that you have, and a quadratic factor makes 2 complex roots. So that's where the quadratic comes from. Notice we only have the quadratics as factors when we have complex roots. So hopefully that helps you out.